This is simply no calculus, just solve. First step, add the 5 over. 2e to the 4x power equals 16. Divide by 2. Again, we want to get the e to the 4x by itself. So it's e to the 4x equals 8. And how do you solve this? Well, you want the x out of the exponent. And some people do log both sides. If you like to use that, use that. I like to basically put the word log in front of this. The e is at the bottom. That's the base of the exponent. So it's the base of the log. And then I just like to switch these two. I think it's real simple. Everybody's different. So again, you basically put a log in front. That's your base. Flip those two. Log base e is actually ln. And then to finish this, you are going to divide both sides by 4. So x is equal to ln 8 over 4. Some of you, by mistake, will kind of cancel this and make this ln 2. You cannot cancel the 8 with the 4 because it's inside the natural log. Now, you could also make this a 4 squared, a 2 to the third. Got it? And take a 3 out. You can do all sorts of different simplifications. You can make it 4, 2 to the third and move the 2 out front, but this is good enough. All right? Now, there's no extraneous solutions. Anything can be plugged into an exponent. Now, for this, we want to get the ln by itself, so we're going to minus the 4 over. So you got negative ln x plus 5 cubed equals 18. Divide by negative 1. We now have ln. Oh, wait. Before we do that, let's actually take this 3, put it out front. Okay? So we put a 3 right here, and then divide by negative 3. That might be easier. Got it? I took the 3, put it out front. Then I divide by negative 3. A lot better to do that. I'm glad I noticed that. So you have x plus 5 equals negative 6. That kept us from an extra step. Now, hopefully you realize there's a base e here. You could exponentiate to get rid of that natural log so you get the x inside. I like to, again, just drop the natural log, base e, and then I switch these two. So when you switch these two, you have e to the negative 6 equals x plus 5. And then you minus 5 from both sides, and you get x equals e to the negative 6 minus 5. All right, from there, that is my answer, but you have to check to see if it's extraneous, meaning you are not allowed to put negatives into a natural log. Will this create a negative number in here? Well, once you plug it in, won't the negative 5 cancel with the positive 5? And then e to the negative 6. Natural log e to the negative 6. You might think, oh, it has a has a negative. But won't that negative just jump out front? Won't this basically be negative 6? Can you solve this? Yeah, you could put negative because, again, this could jump out front and you have e to the ln of e, which is 1. Other way of thinking of it is this is 1 over e to the 6th. 1 over a very big number is close to 0. It is still positive, though. So this is not extraneous, but make sure you check to make sure it's extraneous, if it is extraneous. Last one. If we derive this, real simple. The derivative, this is a product rule. People tend to miss it. Derived x squared, that would be 2x. Leave e to the negative x. Plus, leave the x squared. And this right here, the derivative of e to the negative x is e to the negative x. You just leave it. But then you derive u, the top. And the derivative of negative x is negative 1. So you have to multiply by negative 1. That's very easy to miss that little piece. And that looks like we're going to get, what? 2x over e to the x This minus comes up here, so we have minus x squared over e to the x. They're both the same bottom. Yay. That makes it easy. 2x minus x squared over e to the x. Now, could I also pull an x out of the top if I was trying to set this equal to 0 or something? Yeah, but this is decent for now. You could have pulled out a GCF.